teaching experience in various subjects like Python, machine learning, deep learning, and also various machine learning subjects. He's currently pursuing his PhD in machine learning and has completed his BTech and MTech prior to that. So today's session is about talking about decoding confusion matrix, which is a very important topic when it comes to machine learning. So I would ask Professor Amir to please take over the session. Thank you.
Thank you, ma'am. Thanks for my brief introduction. So first of all, let me know, am I audible enough to everyone?
Yes, sir, you are.
Okay, fine. So let me share my screen. Ma'am, can you just confirm about the...
The screen is visible.
Okay, fine. Thank you. So yeah, today's topic is about decoding the confusion matrix. All right, so this is more specific topic than the more general topic like we have decoding the machine learning or talking about introduction to machine learning, right? So confusion matrix is about classification. We have something called classification into machine learning, right? So before even I start with confusion matrix and classification, let me give you a brief about machine learning and what are the types of machine learning that we have. So machine learning, the algorithms of machine learning are basically divided into supervised and unsupervised learning algorithms. Okay, and into supervised learning, we have something called regression and something called classification. So as far as regression is concerned, we have our predictive the y that we have to calculate as the continuous value, basically. Okay, like for example, I want to predict the price of flat. So the price has to be continuous, right? That will be a continuous value. Whereas the second type is is about classification. So what is classification? The y that we have to finally predict is categorical, basically, like sort of yes, no, or we are predicting a few number of possible outcomes. All right, so for example, I am just taking up today, I'll be just going with the example of COVID, right? So I have a data set where I have a lot of parameters, and based on those parameters, I am deciding on whether a person will be having COVID or not. All right, so here my y becomes predictable. What I have to predict here is whether that person is having COVID or not. Okay, yes or no. COVID, yes, or COVID, no, basically, right? So confusion matrix is about classification. It's an evaluation matrix that we use for classification only. It's not for regression. All right, so that was all the basic about the supervised learning and about classification. Okay, so let me talk about what topics we will be covering up today. While decoding about confusion matrix, there are a lot of things that are related to confusion matrix that I will be talking about today. So we have something called accuracy, we have something called recall, precision, specificity, and F1 score. So these are the things that I will try to explore, and I will make sure that you understand each and every concept very clearly. Now, as far as your data science interviews are concerned, this is something very, very important topic, because as the name suggests, it will confuse you a lot. Especially when you start decoding recall and precision, it will confuse you a lot. All right. So I will make sure that you understand each and everything clearly here. So let me just show you about what exactly our confusion matrix looks like. There are a lot of, different ways in which this can be represented. I'm going with, this way. On left hand side, what I have is actual class, and on the top, what I have is the predicted class. All right. So let me just go and show you this PPT. I just have it for my reference. So I will be going more on to the whiteboard, and I'll be explaining you in detail about a confusion matrix here. Okay. So as I said, let's take a real-time example. For example, I have a data set where I have been given with COVID patient data. Okay. And into the whole data set, the total number of rows that I have is 100. Okay, 100 rows data I have. There are a lot of columns. Okay, I'm not focusing upon independent variables. Let's just focus on my dependent variable. My dependent variable or my y is, I just want to know whether the person is having COVID or not. Okay, so I will go with COVID as let's just name it to C, and let's name not COVID to, for example, H. Okay, so my data set will look something like this. There are factors X1, X2, X3, X4, right? These are different factors. And based on it, I have finally my Y as maybe COVID or not COVID. Okay. Now, what is this data? This data is of already checked or tested people, right? And these are confirmed cases. We're sure about this data. All right. When it comes to machine learning, the most important thing for us is whether the data is accurate or not. So if you don't have accurate data, nothing will work out for you. Data has to be accurate. So that's my, again, first assumption that I'm going with. I have done pre-processing. I have done EDA process completely, and my data is clean. And I have applied some model on it. Okay. So it's like I have applied machine learning already. Now my model is giving me the output. I am predicting something out of it, right? Now I am just checking out of all the data that I am testing on my model, how much my model is predicting correctly, right? So what I have is the actual Y, okay? And what we will be doing is the in machine learning, predicted value of Y is denoted by Y hat. So now I just want to check my actual value was this, for example, C. And for the C, what model my model has predicted, whether it is like C only COVID or maybe not COVID. Okay, that's the case now. So even before going on, I just want to brief you about one more concept called as cross validation. Okay. So actually what we have is like, for example, we have a huge data set. Maybe we have around 1,000 rows. Out of those 1,000 rows, we are keeping around 900 rows for training purpose. Okay. And there are 100 rows that we keep it separately. We don't train this 100 rows with our model, right? So we give these 900 values to our model to train, right? Our model will get trained on these 900. And after our model is already trained, now we will try to predict for our model with this 100 values. How? For these 100 values, my model will be predicting. So you can understand now that for these 100 values, we already have our actual values, right? Now, we will be predicting and we'll be just checking out. It's just as the name suggests, cross validation. We are validating, we are cross checking it, whether my model is correctly predicting things or not. That's it. Clear? And for that case, confusion matrix is really important as far as classification is concerned. All right. And let's just go with an example where I have 100 values, for example, where I'm just taking out COVID and not COVID data. Okay. So for example, it's a balanced data set where I have 50 COVID patient data and 50 not COVID patient data. Okay. So you can just see now, out of this COVID, 50 COVID patients, my model is now, I have just given this complete 100 rows to my model, and it is not predicting. Okay. And now it has predicted that out of 50, it has correctly predicted, mark my words, correctly predicted 40 as COVID. And it has wrongly predicted 10 COVID patient to be not COVID. Getting? So this is what true prediction or correct prediction. And this is wrong prediction. Getting it? Now, let's talk about not COVID. Okay, there were 50 non-COVID patients, out of which my model has predicted 45 people correctly. Okay, out of 50, 45 are predicted as correctly, means not COVID. All right, and 5 are wrongly predicted as COVID. So these 5 people were actually COVID, no, were actually not COVID, but my model has predicted them as what? COVID. All right. So this is the scenario. Let's just decode the scenario in our confusion matrix now. So let me just go with some other color. Let me just use this. I'll be telling you the difference in representation of confusion matrix, because you will encounter different representation, different books and different like videos basically. So I am going with this to be the actual, okay, and this to be the predicted values here. All right. Now, Actual simply means actually it was positive or negative. Okay, means my actual values of y. And predicted simply means what my model has predicted it to be. Clear? Now see it here. Among these two classes, we will consider one class as positive class, one second class as what negative class. All right. Just for simplicity, guys, I am going with two possible classes. Okay. Here I'm just going with COVID or not COVID, right? There can be multiple as well, and for multiple, you can have a confusion matrix for them as well. Okay. But just to make you understand about confusion matrix, I'm going with only two, that is binary classes. There's two classes only. Okay. Now I am considering positive to be COVID positive. Okay. P simply means my COVID, and not COVID simply means my negative class. Okay. Not COVID, non-negative simply. So I am writing it here P, and here I am writing it to be what? N. Okay. And you can see it here as well. We will be writing the same classes. What class we have? P, and the possible second possible is N. Okay. Let's just name it to be PC so that it will be more clear to us. For like positive COVID, negative COVID, positive COVID, and negative COVID. Okay. Now let's just try to write the values here of the scenario that we have taken here. Now we said out of 50, there were 40 cases of COVID, which my model has predicted correctly, right? So positive COVID, see it here. Actually, it was positive, and it is correctly predicted as positive, right? So here, these value will come up. Here, I'm writing that values to be 40 values. Clear? Now, there were 10 COVID values. Actually, it was positive COVID, but they are wrongly predicted as negative. Is that clear? So these 10 value will come up here. Right, everyone? 40 and 10 here. Like I said here, 15 not COVID patients I have, out of which 45 my model has correctly predicted. Say it carefully. Don't get confused. It's not wrongly predicted. It's correctly predicted as not COVID. And 5 are wrongly predicted as COVID. You can see it carefully. It was actually not COVID and predicted at not COVID. These value will go here. So 45 number will come in. Okay, actually not COVID, predicted as not COVID. Similarly, you can see it here. It was not COVID and wrongly predicted as positive COVID. All right, so I'm writing that value here. Actually COVID, actually not COVID, predicted as COVID. Okay, now let's understand the real scenario. I mean, with this, what is the problem here? Into my model has taken the 50-50 data, balanced data set, and it says, according to it, you can see it here, 40 are correctly predicted, but there are 10 people with this model which are wrongly predicted as not COVID. This is dangerous, right? Now, just imagine we have applied this on at some place where COVID is spreading, and it has wrongly predicted for 10 people out of 100. Okay. And now those people are just roaming around. This can be potentially dangerous for us, right? Similarly, this is also dangerous for us. There were 5 people which were actually negative, but we have given them heart attack by saying them that you are COVID, right? Now, for these 5 people as well, you can see it here. Positive class predicted as positive class. We call this as true positive. We call it as TP, true positive. Okay, I can see it here. This one as well. NC truly predicted as NC, right? Negative class correctly predicted as negative class. So this becomes TN. This TP and TN is easy to understand, right? Correctly predicted. So when you have correct prediction, we say it to be true. And when we have wrong prediction, we say it to be false. Clear? Into confusion matrix terminology. So we have this to be TP and TN. Let's try to understand what words we'll be having for this and this wrongly predicted values. Actually, it was what? It was positive, right? But wrongly predicted as negative. So falsely predicted as negative. That's how you have to write. False negative. Okay. And see it here. What about this? Actually, it was not COVID negative, but it is wrongly predicted as positive. So we will be calling it as what? FP. Falsely predicted as positive. Okay. True is easy to understand. Now we will make more, I mean, clear with Fn and Fp. Okay. So when I say Fn, false negative, simply means what? What is it actually? It is actually true, but wrongly predicted as what? It was actually positive, but they are wrongly predicted as negative. That is Fn. Okay. Similarly, false positive simply means what? They are falsely predicted as positive. So what can be falsely predicted as positive? Negative values. Is that clear? So these four terminologies are, I mean, very important for us. Okay. And now I was just telling you that there are different versions of confusion matrix that you will see into different books and different videos. I'm just going with Python's, representation of it, actual and predicted. And this is the way. Okay. What can be different, version of it, different version of representation? Here they write predicted and here they write actual. Okay. Or there can be a other possibility where they take negative here and positive here. Okay. Negative here and positive here. But at the end, what you need to understand is where you are having like positive correctly predicted as positive, you will always have TP. And here, positive, which are wrongly predicted as negative, will be here. Positive or negative, which is wrongly predicted as positive, will be here. Negative, which is correctly predicted as negative, will be clear. And now, one more statement into machine learning. This is called FP, is called as type 1 error. Okay. As far as evaluation and few other things are concerned, this becomes really important for you to understand what is type 1 and type 2 error. Okay. So FP is what? Type 1 error, whereas false negative is called as type 2 error. Okay. We'll I mean, understand this with precision recall as well. Like what is more important for you. Okay. So this was all about your confusion matrix. I hope this is the simplest way that I can explain you or decode you the confusion matrix. Okay. Any doubt, anyone, with confusion matrix now? Actual and predicted. You just have to remember. You have to write here the values and here as well. Whatever is wrong, correctly predicted, you have to write like positive correctly predicted as positive will be here. Negative correctly predicted as negative will be here. And positive which are wrongly, falsely predicted as negative will be here. And negative which is falsely predicted as positive will be here. So the crux of whatever I have explained you is you need to understand the meaning of Fn. Fn simply means false negative, means there were positive values, but they were wrongly predicted as negative. I'm repeating it many times because this becomes very, confusing once you start explaining it to others. Okay, especially into interviews as well. Now, what is FP? They are falsely predicted as positive, and in actual, it were what? They were what? Negative values. Okay, so I hope you got it. And the second thing that I have is about the accuracy. Now, confusion matrix, I hope you understood. Based on confusion matrix, there is something that we have that we call it as accuracy. Let's understand the meaning of accuracy in normal terms as well, guys. Let's just talk about, I am predicting something. Okay, you're asking me some questions and you have asked me 10 questions, and out of it I have given or I have predicted 5 answers correctly. Out of 10, 5 are correct, means what? 5 are wrong. It's as simple as that, right? So simply means I got 50% accuracy. So similarly here as well, when you talk about accuracy, now let's talk in terms of confusion matrix. Okay, what are correct predictions that we have made into this model? That the example that we have taken, TP and TN are the correct answers. Do you agree? Right. So accuracy, the formula of accuracy is TP plus TN. divided by total number of elements. Okay, how many elements we have? 100. You can just count it here as well. 40 plus 10 plus 5 plus 45. That becomes what? 100. So TP plus TN will be there, but apart from it, we need to have FP plus FN as well. That makes your, this comes to your accuracy. Okay, that's your accuracy basically. Okay, now you can see it here. I just want to know, this is our model. That's what it has predicted. So what is the accuracy of my model? You can simply understand using this, and you can just put up the values that we have calculated. It's 40 plus 45 divided by, we know this, it's 100 basically. So it comes out to be how much? 0.85 or 85% accuracy. Just multiply this with 100, that becomes the 85%, right? So 85% is the accuracy of my model. We are fine to go with this, right? Now, when it comes to classification problem, we have taken the very good data set, I would say, because this won't be the case, guys. Try to understand COVID, not COVID, when we are checking out on a huge population. Now, imagine the case right now. Okay, in India, we are just taking out in Mumbai, for example. I'm just checking out how many people are having COVID. So majority of the people won't be having COVID. It's almost gone, right? So out of maybe 10,000, we'll find one or two people. So data set won't be so much balanced. It will be very imbalanced data set, right? So let's just take an example of imbalanced data set where I'll be like try to explain you why accuracy is not actually a good measure for your model. Okay, now let's just go with the COVID and not COVID only. I'm just writing COVID and NC means not COVID. Okay, now I just have 10 COVID patient. Okay, and I have 90, for example, non-COVID patient. Now, what happens is, see, my data is very well trained on not COVID, but not really good train on COVID. Okay, I'm not going into the like how to balance the data from imbalance. There are techniques like SMART and all. I'm not going into the detail of it right now. I'm just showing you why recall and precision. Are important when even when you have accuracy. Okay, so now let's just understand. Okay, out of non-COVID, my model has correctly predicted all of them as not COVID. All of them, okay? And zero wrong prediction. Okay, all correct prediction, but zero wrong prediction. You can see it here for COVID. My model has predicted all of them as not COVID. Okay, this is the worst model you can understand. All 10 COVID patients are wrongly predicted as what? Not COVID, and zero correct predictions, right? Now let's just try to understand. Let's just try to, go with its confusion matrix. Again, I have actual and here to be predicted, and positive class and negative class here, and positive and negative class here. Let's just decode it. What values I will be having here? Positive, which are correctly predicted as positive, 0. There's no correct value that my model has predicted. And here you can simply see my FN falsely predicted as negative here. That's 10 value. And now NC is something that we have all correct prediction. Simply the value will be here and wrong predictions are here, right? So that's my confusion matrix for this example. Now you can see it here. If I just go with accuracy, simply if I go with accuracy, the problem here is the formula is what? Correct predictions divided by total number of it, right? So how many correct predictions I have? 0 plus 90. 90 divided by how much I have? 100. I am getting, guys, I'm getting 90% accuracy for a model, which is actually worst model. Getting? This is the biggest problem with accuracy. And this problem will occur when you have imbalanced data. And majority of the time, believe me, we will be having imbalanced data when it comes to the real world problem, like a patient having COVID or not, or maybe you're just checking out how many people will have cancer. Okay, in the first stage or maybe in third stage. Majority of the people that you are checking out won't be having cancer, right? So the data, majority of the time, it will be imbalanced data. So now what is the solution? The solution is into something called as precision, recall, and then we have something called as sensitivity, right? Let me just go to my, yeah, this is one of the representation. I told you there are different representation of confusion matrix, right? So here you can see it here. This diagram has taken negative here and a positive here. Okay, and for that reason, FP comes here, TN comes here. You can understand, right? So Nothing will change inside it. You have to be very careful while writing it. Okay, TN simply means negative predicted as negative, right? So I'm going into detail once again. So going to the next slide. Yeah, this is the accuracy TP plus TN divided by total number that we have. Now there's something called recall that I want you to understand. See the formula of recall. Recall says TP upon TP plus Fn. It's just taking TP upon TP plus Fn. Okay, we'll be talking. We'll be going back to our uh, this whiteboard, and I'll be explaining it there. Meanwhile, you just see the formulas. Okay, so that's the formula of recall. And then there's something called precision. Okay, the most important thing that I want you to understand is it's not taking everything. Okay, the way accuracy is taken, recall is just taking TP. Okay, it's not taking TN into consideration. Okay, and what exactly that mean, we'll decode it as well. So precision is like TP upon TP plus FP. So instead of false negative, it has taken false positive. And what does that mean? Let's just see that as well. And there is one more specificity, TN upon TN plus FP. Okay, and then comes one of the most important measure of classification, that is F1 score or F score. So it's like 2 times RP, that is recall and precision, divided by recall plus precision. Okay, these are the formulas, guys. I just wanted to have, just wanted to show you the formulas. Now, let's understand one by one. I'm just starting with recall first. What we use it majority of the time. Okay, so you can see it here. The formula of recall was TP upon TP plus Fn, right? Let's just try to decode in terms of my confusion matrix again. These things are very easy to understand when we try to understand it through this confusion matrix. So again, I'm just writing it here. Here is my TP, right? Positive, negative here, and here positive falsely predicted as negative, negative falsely predicted as positive, and negative correctly predicted as negative. Okay, this is what I have. Let's just try to decode. It is taking TP. Okay, this thing it is taking plus, divided by TP plus Fn. It is considering this only. So what it is trying to give us? It is trying to give us from all the positive values, how many are correctly predicted as positive. Do you agree? That is what recall is. It is not considering about negative class. It is just focused on the positive class. If you want to just focus on negative class, we have specificity for that. Okay, and this is for recall. This is stats term, guys. You have to remember these terms, and you have to remember these terms. There's no other way possible. Okay, but I can just decode it. What exactly recall simply means, right? So recall simply means how much out of all positive values that you have, okay, actual values, how many you have predicted, your model has predicted correctly. Is that clear? So true positives, right? And total, how many positives were there? True positives and the positives which are falsely predicted as negative. So that is the ratio basically that we have. Okay, now where to use it? In the case that we have taken, for example, the COVID wala case, right? So it was the positive class was very important for us, right? And second thing is, this was really crucial. False negative was crucial for us. Do you agree? False negative simply means what? They were positive COVID patients which were falsely predicted as negative, right? FP is important, but guys, try to understand this is more critical for us. There can be a possibility that there were some people, those who were negative, but they were falsely predicted as positive, and we have treated them. For treatment, they won't be, it won't be really, that it will be harsh for them only, right? For that individual person, but not for the whole population, right? But this can be potentially dangerous for us. Even if a single person which was COVID, but my model has wrongly predicted a person as negative, he can, I have given the certificate of negative COVID, right? COVID negative certificate I have given, that person is roaming around. It is threatening for his life and for others as well, right? So we have such a lot of examples, especially when it comes to medical conditions, guys, where we are just thinking about whether a person will be having some disease or not, right? So this can be very crucial for us. Is that clear? So in such cases where your false negative is very important, you will be going with recall. Clear? Now, going to the next example that we have, precision. We just have seen the formula of it. Compared to recall, the formula only changed with Fn being replaced with Fp. So it is Tn upon, sorry, Tp upon Tp plus. Here it was what? False negative. And here we need to take false positive. Now what it is giving us, try to understand. This is decoded. Tp upon Tp plus Fp. So Tp upon Tp plus Fp. Now, this is more about prediction. Okay, this recall was more about, out of all the things actually that we have of positive, how many positives are correctly predicted. That there was a ratio of recall. But precision is more about prediction. Out of all the predictions that is done for positive, how many are correctly predicted as positive? Okay, so it is Tp upon Tp plus Fp. So you can see it here, guys. I have used a word here, if you remember. Fp is called as what? Type 1 error, whereas Fn is called as what? Type 2 error. You can just imagine. There can be a question to interview, like what recall takes into consideration. Which type of error your recall takes into consideration, type 1 or type 2. So Fn is what? Type 2 error. You can simply say recall considers type 2 error, whereas precision takes into consideration the type 1 error. Basically. Okay. Now, coming to the next thing that we have, apart from precision, I told you, there can be a possibility that you are more concerned about negative class. The best example can be like you just have built a model for checking whether the mail that you have received is spam or not spam, for example. Okay, so just try to understand. Let me just write that example as well. So spam detection. Okay, there comes the mail. Majority of the mail will be what? Not spam, right? But let me just write spam mail or not spam. Okay, so you can see it here. Any mail which is not spam is wrongly predicted as spam. What can be the potential danger for this? And it was negative, but wrongly predicted as positive now, right? Getting it? So your concern is more about negative, which is predicted as positive, right? So here we can understand we are concerned about negative class because you have a mail. For example, you have got a mail from a company of joining later, and your model has predicted it wrongly to be spam mail, and it went into spam. And because of like you haven't seen that offer letter, your offer letter is rejected finally. Getting? So this becomes dangerous for you. Getting it? So there will be cases, guys. I'm just showing you one of the scenario. There will be a lot of such scenarios where your negative class is more important for you. So in such cases, you would be going with what? Something called as specificity. It's a statistics name, guys. Specificity. Okay, that's how you write it, specificity. All right, and the formula of it is Tn upon Tn plus F. And you can simply decode it, guys. This is more about negative class, right? So among all the negative class that is there, it's just reverse of recall, you can say. Recall is for positive and your specificity is for your positive negative class, right? So Tn upon Tn plus Fp, wrongly predicted as F, falsely predicted as positive. And this is again, Fp simply means what? They were actually negative. Okay, sorry, here, Tn upon Tn plus Fp. Is that clear, guys? That's what we have is as what? Specificity. And when you will be using specificity, when your model into your system or into your data, you're more concerned about the negative class. Clear? I hope you got it. Based on confusion matrix, these were really important concepts. Okay, let me just quickly revise it once again. Accuracy was for balanced data, and when you're least bothered about precision recall, you want to consider everything. In short, false negative as well as false positive. For that case, accuracy is the best friend of yours to check or to measure the accuracy. All right, so its formula is simply like how many like correctly predictions by your model as TP and TN, and divided by total predictions TP, TN, and FPFN as well. So that was all about accuracy. And then we have seen one more example where you have an imbalanced data set, then your accuracy is actually not really good for you. So in such cases, if you're more concerned about positive class, you will be going with the recall or precision. And if you're more concerned about your negative class, for that case, you will be going with your specificity. All right. So, and into it, again, recall is more about the actual values that you have taken. So the formula is TP upon TP plus FN. Just remember the formula. And from this, you will be able to like recall the formula as well, guys. So TP plus FN, right? And this is what this is about precision, right? And this is about the specificity. Simple, guys. First, you can see first row, top row is for recall. This first column is for your precision, and this lower row is for your specificity. That's the simplest way to remember the formulas of it. If you try to explain anyone with TN, FP, and TN, you will get confused, guys. So whenever you're explaining to anyone, make sure that you recall your confusion matrix correctly. Then only try to decode or recall precision now. All right. So based on it, guys, there's something else that we have. And I've written, I told you as well into the slide as well, that is F1 score. Now, there can be a possibility that it's imbalanced data and you don't want to go with recall or precision, or you don't want to go with even specificity. For you, I mean, FP and FN both are important. Okay. So in such cases, you don't go with accuracy or recall or precision or specificity. You go with something called as F1 score, which is combination of your precision or recall. You can, from the formula, you will be in a position to understand it, guys. It's simply 2PR, that's 2 into P into R divided by P plus R. Harmonic mean of precision and recall. Okay, that's harmonic mean of precision and recall. Okay, P into R divided by P plus R. Is that clear? So you can see it here. You can go with F1 score in such cases. But frankly speaking, in majority of the cases where we are concerned about positive values, we go with recall. Okay. And when you are considering only negative values, you're concerned about only negative values, you go with the specificity. Okay. So that was all about this, guys. And I want to show you one more thing that is related to the implementation of it. Okay. I won't be coding the whole thing because we don't have much time to do it. So we share the screen and show you the code that I have already done. Okay. So I have done I have taken the two codes here, guys. I hope it's visible to everyone. Can you confirm, ma'am, is my collab file visible? We share the screen once again. I guess there's some problem. Is it visible? Okay, fine. So you can see it here now. I have taken a small data just to like understand you the working of precision recall. And always what happened to machine learning is you start with EDA process. Okay, I'm skipping everything because I want to focus on the confusion matrix. Okay, so just to brief you about machine learning and the steps that we consider while building any machine learning algorithm. The first step is always EDA. We try to explore the data. And believe me, as a data scientist, majority of the time, 60% of the time, at least you give in EDA process, EDA and pre-processing. Okay, you explore the data using, there are a lot of visualization techniques that we have, the libraries like Matplotlib or Seaborn, and there are other visualization tools like Power BI, Tableau as well. So through that, we try to explore the data. Okay, and we try to find out different things like how many missing values are there. So we fill up the missing values. So those things are called as pre-processing. Okay, we do feature selection, we do feature engineering, lot of things that we do into pre-processing basically. Okay, so I'm not going through that. I have done it. Okay, so you got a clean data now. After seeing the data, you will decide on which algorithm to go. Okay, there is again one complete lecture I have to take on that, like how to select the algorithm. Okay, so based on the data, you decide on which algorithm to go with. First thing will be, of course, whether your predictable variable is your classification or regression, right? Based on it, you will be deciding on, or maybe You don't have any label data. For that case, you'll be going with unsupervised, basically. Clear? So here I have taken classification because I wanted to show you confusion matrix, right? So you can see it here. I have created a model here. I mean, using logistic regression, I have implemented here. And then after predicting, I want to show you one thing for that. I told you there is something called as cross validation. Okay. The other example I'll be showing you here, the data set was very small. So I have to check it with this. Okay. So in Python, there is something called as metrics. Okay. There's something called as metrics, which is there into sklearn, basically. Okay. I mean, metrics is again a sub library into sklearn, and into it, there is something called as accuracy score. Okay, accuracy score, which is actually the accuracy, TP plus TN divided by the complete thing, right? So it's showing you the how much accuracy we are getting. You can see it here. I'm getting the 100% accuracy, and for that, let's just take out the confusion matrix as well. So you can see there's one more thing called as one more function called as confusion matrix. So to it, we have to provide the actual value, the real value of y, and also the predicted value of y. Okay, and it'll be showing us this matrix. You can just see it here clearly. What is this? 3003. Positive class. Okay, one class is taken as positive, and other class is taken as what? Negative. You can see it here. All this is here. The way I just explain you is exactly the same. Okay, here is the actual value, and here the top it's predicted. Positives correctly predicted as positive. Positives wrongly predicted as negative. Here it is what? Negative falsely predicted as positive, that is FP, and negative correctly predicted as negative, that is TN. Clear? You can see it here, 3 plus 4, that is all are predicted as correctly. I just have a small data set of 7 rows, guys, and a logistic regression is doing wonders with this, predicting 100% accuracy. Okay, and there is something called classification report. We don't have to write, or I mean, we have to calculate it, guys. We have everything into sklearn library to calculate everything. Okay, so into metrics library, again, we have something called as classification report. Again, to it, we have to pass on y and print actual value of y and the predicted value of y, and it will be giving us precision, recall, F1 score. It's complete things it is giving us. Is that clear? So classification report is what we can see it here. And now going to one more example that I have like taken. So here again, it was Titanic data set. You might have heard about Titanic competition as the basic competition that generally data science students start with on Kaggle site, right? So I have done its ED and everything. And then I am trying to, there it was like Titanic, how many people survive into when Titanic was sink. So based on it, I have the data set, and I was just telling you about cross validation, right? So into cross validation, there is one technique called as uh, data split, basically. Okay, so we have that into model selection. What we do is we have a data set, right? We divide our data set into training set and testing set, where train is the data with which we will train our model, right? And testing, we will be giving it for, like, once our model is created, we'll say, okay, this is my X value. Tell me what is your answer for this. Predict the Y value for it. Okay, and it will predict, and that will be my Y print, basically. I hope you are getting what is the meaning of actual prediction and the prediction, actual values and the predicted values, basically. Okay, so now that's how you, I mean, split it. And I have created the logistic regressions through sklearn only directly. And then here you can see it here. This is something that the wrong answers that we're getting up here, guys. 139 are correctly predicted as people who survived. Okay, and here this is about how many people died. 72, right? 31, you can see these are FN, falsely predicted as negative. And here as well, 26 are wrongly predicted. 26 negative are predicted as positive. Okay, that is FP, basically, falsely predicted as positive. I can see it here. For this, I just went on to check its accuracy. So this is giving me accuracy again, not precision recall. It's just giving me TP upon TN plus TP plus FN plus FP, basically, divided by. Okay, 78 78.7 is the accuracy that I'm getting. And it will be in points, guys. You just have to multiply it by 100 just to get the exact value in terms of percentage. Okay. And again, you can see it here, classification report I'm writing. So giving me precision recall F1 score values that we have seen basically. Okay. So that was all about precision and recall. I hope you understood it, each and everything. And there is one more thing based on it, guys. I mean, I have to take one more session for it that completely that will require around 1 hour for me to explain. That is ROC-AUC curve. Okay, ROC-AUC curve is also based on it. So it's basically FPR versus TPR, basically for different models we draw it. Okay, so I hope you understood each and everything, and I hope I have decoded confusion matrix in the easiest way possible. Any questions from anyone? Do I have any questions from anyone on YouTube or here? Okay, fine then. That's it from my side.